In this video, we are going to continue our investigation and practice with properties of exponents. To start the video, what I'd like you guys to do is spend a little bit of time and do examples 1, 2, 3, and 4 in the warm-up on your own. So pause the video and attempt 1 through 4 on your own now. Now that you've tried these on your own, I'm going to talk through how I think through these problems. So when you look at number 1 and number 2, number 1 and number 2 look very similar. The only difference is there's parentheses here and not here, which we've discussed changes what the base is. So the base in the first expression is just the 5, meaning it's really -1 times 5 squared. Whereas the base in the second expression is -5, meaning that's -5 times -5. So if I simplify this, -1 times 5 squared is really expanded to that, which gives me a -25. Whereas -5 times -5 will be a +25. And if you punch it in your calculator, and you don't have the parentheses, it'll tell you -25. It does this kind of work in the calculator. Now if I include the parentheses, now it tells the calculator to multiply -5 by itself, which is 25. Moving on to the next one, these problems look very similar as well. We just have the different exponent in the denominator. So if I were to expand this, this would be a times a times a, divided by a times a times a. And if I divide these out, they all divide to be 1. So my final answer is 1. Over here, if I expand these out, I have a times a times a in the numerator. I have a times a times a times a times a in the denominator. And I divide these out, that's 1, 1, 1. What I see is I have a squared remaining, but a squared is in the denominator. So if I think about this, in the numerator, I have to have 1, because those divide to be 1, over a squared. So this uses what we did yesterday and actually leads us into what we're talking about today. So before I go back to this to explain how it implies what we're doing today, I want you guys to go ahead and take a look at investigation number 5. And then we'll use investigation number 5 along with example 3 to talk about what it means to raise when you have an exponent of 0. So go ahead and with your partner in your groups, go ahead and take a couple minutes to do investigation number 5. Pause the video right now, and then when you are finished, start the video again, and you'll see my worked out explanation. All right, now that you've tried this on your own, I'm just going to fill in the table. So I have 2 to the 0. I'm not really sure what that is. I could punch in my calculator, but if I'm doing this without a calculator, I'm not sure what that is right now, but 2 to the first I know is just 2. 2 squared is 2 times 2, which is 4. 2 to the third is 2 times 2 times 2, or 8. 2 to the fourth is 2 times 2 times 2 times 2, or 16. And what we can see is there's this pattern, right? We talked about this pattern in exponential tables before, that we are multiplying by 2 each time. So then if you follow that pattern to work backwards, we would divide by 2, and we get 2 to the 0 is 1. If we do that same pattern, 3 to the first is 3, 3 squared is 9, 3 to the third is 27, 3 to the fourth is 81. Again, you have a pattern here of multiplying by 3. So if I want to work backwards, I would have to divide by 3, and 3 divided by 3 is 1. So again, 3 to the 0 is 1. And then over here, 4 to the first is 4. 4 squared is 16. I'm not as good at doing these in my head, so let's do 4 to the third, or 16 times 4 is 64. If I follow that pattern and I multiply by 4 again, I get 256. So again, the pattern here is that you are multiplying by 4 each time. So again, to work backwards, I would divide by 4, and 4 divided by 4 is 1. So it asks us, use the table to observe what happens when you have an exponent of 0. What conclusions can you draw? Well, what I'm seeing is an exponent of 0 are all of these. Anytime I raise something to a power of 0, I will get 1. So anything to the 0 power is 1. That is the summary or the conclusion we can draw, which some of you guys might have seen this already in example 3. Using the pattern that we discussed yesterday, example 3, you might have said, well, if I'm dividing and I have the same base, I can subtract those exponents. So that would be a to the 3 minus 3, or a to the 0 power. But we show when we expand it, it actually is 1. So a to the 0 is equivalent to 1. So what I want you guys to do right now is pause the video and try example 1, A, B, C, D, and E on your own using this new idea that if you raise something to the 0 power, if you have a base to the 0 power, that would simplify to 1. Pause the video now, try these on your own, and when you're finished, press play. Now that you've tried these on your own, I will talk through how I think through them. So negative 2 to the 0 power. Well, if I look at what my base is, because I have the parentheses, all of negative 2 is to the 0 power. And anytime I have something to the 0 power, that's just 1. So my answer is 1. This time, the base is x. It's only x. So I have this expression right here is 1, but I'll have negative 3 times 1, which is negative 3. Over here, I have parentheses, so this whole thing is the base. Anything to the 0 power is 1. This time, if I simplify, 4 times 2 is 8. I have 8 to the 0. Again, that whole thing is the base, so I have 8 to the 0 is 1. Over here, the only thing being raised to the 0 power is the 2, so I have 4 times 1, so my answer is 4. So you just have to be careful to see what is being raised to that 0 power. All right, so I want you guys to pause the video as you work on investigation number 6. When you're finished with the investigation number 6, I will press play and I will talk through how I thought through investigation number 6. All right, so we know that 2 to the 0 is 1, 2 to the first is 2, 2 squared is 4. And we talked about if you follow that pattern, you're multiplying by 2. And to work backwards means I have to divide by 2. Well, 1 divided by 2 is 1/2. If I divide by 2 again, I get 1/4. Over here, anything to the 0 power is 1. 1/3 to the first is 1/3. 1/3 squared would be 1/3 times 1/3. So I'll just do that to the side. 1/3 times 1/3. So you guys can see this. 1 times 1 is 1. 3 times 3 is 9. Here, I am multiplying, let me do that in the same color. I'm multiplying by 1/3 each time. So if I work backwards, I could divide by 1/3. But dividing by 1/3 is the same as multiplying by 3. So 1 times 3 is 3, times 3 again would be 9. Over here, anything to the 0 power is 1. 4 to the first is 4. 4 squared is 16. Again, I can follow this pattern, times 4, times 4. Working backwards then means I need to divide by 4. 1 divided by 4 is 1/4. 1/4 divided by 4 would be 1/16. And I'm leaving these as a fraction intentionally because you can see a pattern here. I have 1/4 and 4, 1/2 and 2, 9 and 1/9, 3 and 1/3, 1/16 and 16, 1/4 and 4. So there is a pattern. So it says, use the table to observe what happens when you have a negative exponent. What conclusions can you draw? And what we're seeing is, if I rewrite this using a base of 2, this is the same thing as 1 over 2 squared. This is 1 over 2 to the first. Negative exponent here, or let's go down. So this would be the same thing as 3 to the positive first. This would be the same thing as 3 squared. Over here, this would be the same thing as 1 over 4 squared. This would be 1 over 4 to the first. So if I'm looking at these negative exponents, what I'm seeing is 2 to the negative second is the same thing as 1 over 2 to the second. 2 to the negative first is the same thing as 1 over 2. This relationship is called the reciprocal. So when I raise a negative exponent, or I have a negative exponent, it's the same thing as raising a positive exponent, or raising that reciprocal to the positive exponent. So what that means is, if I have, for these two, if I have something to the negative exponent, we'll say a to the negative b. I do the reciprocal of a, 1 over a, and I raise it to the positive exponent. You can either look at it as to the positive b, but what we know from earlier is that would just be 1 to the b, or 1 over a to the b. So these are equivalent. So this is a new idea. You do the reciprocal. Over here, if I have that same idea, if I do 1 over a to the negative b, then that would be equal to the reciprocal to the positive power. 1 over a is just a over 1, or a to the positive exponent, or you could just leave it as a to the b. What some students say is they'll look in the denominator. If a number's in the denominator, it gets moved to the numerator and becomes positive, or if it's in the numerator, it gets moved to the denominator and becomes positive. It's another way of thinking of it. So these are our new rules. Now, negative exponents and an exponent of 0 are definitely more confusing properties than the previous one, so I want to make sure we get the practice. So what we're going to do next is flip to the page, or flip to the back of the page. This is day 11. We're not doing that. We're just focusing on example 2. So example 2 asks us to simplify these using negative exponents. So what I want you guys to do is pause the video, attempt these on your own, and then when you've finished attempting it on your own, press play again, and I'll explain how I did these problems. Alright, so looking at A, I focus in on A. Using the rule, I can say that's the same thing as 1 over 5 to the second. I can move it to the denominator and make the exponent positive, which is 1 over 25. Here, there's a couple different ways to think of it. You can say, well, it's just the reciprocal to the positive exponent, which would be 5 over 4 to the positive exponent. And 5/4 squared, well, you can think of that as 5 squared over 4 squared, or you can think of it as 5/4 times 5/4. Either way, you'll get 25 over 16. Another way that some students have thought about this in the past is they say, oh, well, that's 4 to the negative second over 5 to the negative second. And sometimes students will see, well, anytime there's a negative exponent and the number's in the numerator, I have to move that down to the denominator, and anytime it's in the denominator it's negative, I move it to the numerator. So this moves to the denominator and becomes positive exponent. This one will move to the numerator and have that become a positive exponent, which we see is the exact same thing. So just two different ways of thinking of the same problem. If I use that same analysis for C, I can think of this the first way as doing the reciprocal, 3 over 1, or just 3 to the positive 4th, which is 81. If I expand that, 3 times 3 times 3 times 3. Or I can think of it as 1 to the negative 4th over 3 to the negative 4th. And again, if it's in the numerator and has a negative exponent, I'll try and move it to the denominator. If it's in the denominator with a negative exponent, I move it to the numerator. So my numerator now is 3 to the positive 4th. My denominator is 1 to the positive 4th. And just like we talked about here, 3 to the 4th is 3 times 3 times 3 times 3, which would be 81. 1 to the 4th is just 1 times itself 4 times, which is 1, or that simplifies to 81. Over here, there's a couple different ways that you can think through this one. You can simplify 3 times 4 first and say, well, that's 12 to the negative second, which would just be 1 over 12 to the positive second. And if I square 12, I get 1 over 144. Another way to think of it is I know if I have a product raised to an exponent, I could do 3 to the negative second times 4 to the negative second, which I make that into its reciprocal, 3 squared times 1 over 4 squared. So that'd be 1/9 times 1/16. And when I multiply 9 times 16, I still get 144. So either way, I can work through those problems. Go ahead and pause the video now, and you should get an exit slip and be able to try and work through those the best you can. And then we're going to go over that exit slip tomorrow. If you finish the exit slip early, you have the remainder of class to work on your homework, which is the day 10 worksheet. The answer key is typed, so you guys can check your answers on that as well. Good luck.